Yeah, let's go ahead. I'm going to get started. So the first thing I'm going to do is upload this file so that you guys have it. So give me a second. So cd classroom, git commit, so git add star.itp/star.txt. We'll learn more about git this. I cannot make it brighter, but I can turn the light off. Yeah, that's terrible. You'd never be able to see anything. All right, can you see something now? That looks better, right? Yeah? Okay, so git add itp.txt. Basically, that's just adding the file I made. So, because I want you guys to be able to run your code on this as well, if you're following along. So, git commit-a, uploaded file. We'll learn more about Git and the ways to use it, but I use a command line for Git because I don't like having to run another program if I don't have to. But what that did is that, let's see, that made essentially a checkpoint for my code, and now I can just upload it online. So type in my password, super secret password, right? And now it's just putting the code online onto the class website, which let's go ahead and see, right? So if you go over here, by the way, if you haven't found this yet, I'm going to point this out to you, right? Because I kind of think this is important, right? Over here on pages, right? So you may not have explored, in which case you should always explore, right? Especially if you see a pages on your Canvas site, because that's something your instructor creates. All right. So I don't know why Congrau made that one, but anyway, there's lectures, right, which is our lecture recordings, which are on YouTube, as I mentioned. And by the way, this is a playlist over here, right? So if you actually click over here, it gives you all the videos that are up, right? So it's not just the first video. And over here is class code, right? So if you haven't seen this yet, right, it just has a link to GitHub, which is was bought by Microsoft sometime last year. It's a very popular place to store your code online. Anyway, and this has code for all my classes, and it's organized into folders, right? So destruct for data structures, grad for graduate for the graduate course, intro for the intro to Java course that we do, and then ITP is you guys, which is intro to Python. So if you click on ITP, you'll find basically a bunch of the files that, not only the files that I did here, but also you'll see there's a folder called Summer 2018, which has all the code that I did in the summer. So it's there for you to peruse. So if you ever are missing the code or you can't figure out quite what's going wrong with it, it's over here. Now over here I just uploaded I should have uploaded a text file. Come on. Testfile.txt, right? So if you want to, you can download that file. And you can download it by just going to raw and then pressing like either Control-S or Command-S, and you can save it to wherever it needs to be. And it's just a text file with some string in it. You can make your own text file, okay? For what we're going to be doing. Today we're going to be learning about both strings and turtles, right? So we're not fully done with turtles. Might as well use turtles with what we have. Because there's actually a number of interesting things we can do with turtles. By the way, if you didn't find this page already, right, or you forgot about it, over here, right, this page, docs.python.org/3/library/turtle.html, which you don't have to memorize. I didn't. Guess how I found it? And I'm going to go ahead and increase the size. I did it by searching by going to DuckDuckGo. They're local to Philly, by the way, interestingly enough, I think. Anyway, I went it by saying turtle Python, and yeah. And then I just simply replaced the 2 over here, because that's Python 2, with Python 3, although the commands are the same, right? And there, so 1966 was the year, right? And then it's got this little demo, right? If you run this, it will do this, which is pretty cool. Anyway, so I'll move this down, but basically it has a list of all the methods here, right? And we've done most of them, Here's one that's useful. Circle. It draws a circle of radius. It also can use to draw a semicircle, right? So that can be kind of useful. Let's go ahead and just test that out, especially since I'm making you do a Olympic ring program, right? Right, so let's go ahead and test this out. So first we'll start by, of course, importing our turtle module. Import turtle, right? And I'm just going to go over a couple of very interesting things we can do with turtle. Import turtle. We'll go ahead and make our turtle Bob again. Turtle dot turtle. Oh, and I'm going to turn Bob dot shape. I like, as usual, I like to make him actually be a turtle because I don't know, I'm silly like that. It's the little things in life that give me enjoyment. And then at the end of it, right, no matter what I want at the end of this a turtle.done. If you forget to put turtle.done on your exam for your code, if I ask you to write some code, don't worry about it. I'm not going to count off because technically it draws the thing that I'm going to ask you to draw, right? So don't worry about it if you forget it on the exam because it's still going to draw the thing. It's just going to go away. You know, that's not what I care about. I care about, oh, do you know how to manipulate a turtle, right? That's kind of the stuff. So, right. So let's go ahead and say Bob is equal to turtle. We've got our shape. Let's go ahead and just test to make sure that I didn't do anything stupid. Great. There's Bob, and he's ready to go. So let's go ahead and just test around. I saw that it had a circle function, so I'm just going to call it, right? Right, and it says something self-radius, right? So we just care about the stuff from the radius. Extent and steps. I don't care, right? So let's go ahead and just draw a circle with 100 and see what happens. Oh, that's nice. So so that gives me a circle. Nice. All right. What the heck was extent though? So there were two more variables I could do. What's 10 and 50? Ooh, 50 degrees. I bet. Let's go ahead and see if I draw 180. So this is a radius of 100. 180. I bet you that means 180 degrees. There we go. Okay. Okay, so if I wanted to do a full circle here, I bet you I could do 360. Right? And if I wanted him to go around and around and around, I bet you I could do this, like 720. Yeah, totally. This will just simply make him keep going around and around, right? 7,200 degrees, right? That's a lot. So it's actually getting more and more black on there. That's interesting. Okay, so anyway, we're just going to stop him where he's at. Yeah, I know, you're sad. Okay, and now let's go ahead and see what steps means. So it said steps on there. So let's go ahead and read the documentation. I literally don't know what this does, by the way. I don't know what steps does. This is literally me finding out alongside you. Okay, steps in integer. So draw an arc in the clockwise direction if radius is positive, otherwise counterclockwise. Extent. Maybe used to steps is the number of steps. As a circle is approximated by an inscribed regular polygon, steps determines the number of steps to use. If not given, it will be calculated. You see, I understood that gibberish, it's terrible gibberish. I think I understood it. So I'm guessing that if I write 3 here, it will draw a triangle. Okay, so here's the thing, right? So this gets into a point. How many sides does a circle have? There's 2 good answers to that. Yes. 3 good answers. Yes. Infinite is one of the answers, or 1, or none. Right? I don't know what the definition is. I'm not a mathematician. Right? But the point being is that it's certainly, not like 12 sides, right? 12 sides is, whoops. Ooh, interesting. That did that. what if I did 24 over here? 24. Again, I'm playing around with this. Right? 12 sides is whatever a 12 sides hexagon is called. Dodecagon. Point being is that, right, that kind of looks circular, right? Something with 12 sides kind of looks circular, but it's not quite. Right? But to answer your question, somebody said, but more to the point, somebody said infinite sides. The issue is that on my screen, I have only so many pixels. I can't draw a true circle. In fact, I can't like change half a pixel or something to be a certain color. Each pixel has basically so your computer screen in front of you is made up of small little squares. If you just get in like this, and now I'm like disturbingly close to the camera, right? It's made up of small, tiny little squares, right? And if you've got something above, basically, if you still got a 1080p screen or lower, you should be able to see them. Higher than that, it gets really hard to see. So if you got one of those Retina displays, which you won't really be able to see it go into there. But each of those is just a small color given with the variable, with a certain amount of red, a certain amount of green, and a certain amount of blue. So we're turning a bunch of squares into a circle shape, which actually doesn't really work too much, right? But the fun thing, at least mathematically, the fun thing is that the human eye doesn't care, right? If I were to actually draw a circle, right? Let me go ahead and I'm going to go ahead and show you what I mean. I'm going to draw. I'm booting up an art program, and I can't paint worth anything, as will readily be apparent. But that's kind of the point here. So while this is booting up, yeah, okay. So let's go ahead and see if I can't even figure out how to use this thing. This thing's like industrial strength. So there's a canvas, and I think I've got it. Can I? Yeah. Okay, so I'm going to draw a circle. Right? Right? I drew a circle, or at least something that approximates a fourth grader's interpretation of a circle. The point being is that if I were to draw a circle, I can't actually draw one. Like, there's going to be some atomic level inconsistency, even if I use like a straight edge or something like that, or a compass and ruler, There's going to be something like that. And so we're getting into that kind of similar situation when we're dealing with circles over here. So that's what the whole steps thing is. It's saying how many sides am I drawing, right? Suppose I put in 100 here. This is going to draw like maybe 100 sideagon. And that looks pretty darn near a circle to me, right? So the computer to display a circle doesn't actually need to draw a circle. That's hard. Instead, it can just draw a 100 sideagon. So when you can so for your draw shape method, just try try telling your turtle to draw like something with 100 sides, and you'll end up getting something that's close to a circle. All right, so that's what the steps was there. And that was completely, I did not expect to be going in that direction, but hey, I was experimenting and having fun with this. And that's what you should do. You should learn to have fun with these kind of things. Don't view it just as work. Try to have fun with it. All right, so, okay. So, now, I do wish that that I could do some more, I could like teach Bob a trick or something. That'd be nice. So let's go ahead and see. We've got something called the onClick command, right? We can make these things interactive. So turtle.onClick. So what we're going to do is that we are going to create a function, and we are going to simply say that is going to be what will happen when we do the turtle command. So let's go ahead and see that. So let's go ahead and just do something pretty straightforward. We're going to say def. Let's see, how do we do this? Do we have to? I have no idea how to do this actually. Let's go ahead and see though. It says def, for example, for anonymous turtle, i.e. the procedural way. Let's see. Okay, def. Oh, I don't need to do any of that. So Bob, let's go ahead and see. Can I do bob.onClick? Yes. bob.onClick, click. And then we gotta just, let's see what happens if I do left. Yeah, let's go ahead and see what happens if that works at all. Nope, left is not defined, it says. Bob.left. Says it takes positional arguments, but 3 were given. Excellent. Bob.left 30. Let's go ahead and see. Do we get anything, or is this going to crash? Again, I have no idea. I'm just trying to play around with this. So on click, it says bob.left 30. Let's see. Add. So how do I? Okay. So, let's see. Sorry, I looked at this like a half an hour before class, and I thought it was simpler than it was. So, let's see. Def. You know what? Let's have some fun here. Def say hi. We're going to keep this pretty simple. Print hi, right? So we've defined a function called say hi, which will just print out hi when it's called. So what we'll do is we'll say bob.onClick, and then we pass it the function name, say hi. Now, if you're coming from another programming language, this looks really weird. Because you can't do this in a lot of other programming languages. But this should read pretty much like English, right? On click, say hi. Say hi takes in 1 positional argument, but 2 were given. What was it? What were you given? What were you given? X, Y? Let's see. It says 2 were given, so let's go ahead and say X and Y, and let's see what they are. Again, I'm just figuring this out from reading the error messages. Aha. So it's telling me, so when I click, on click, what it does is that it gives me 2 things when it clicks. So it's saying, here's the 2 things I would like. So here's the coordinates. So if I click here close to its head, it's giving me the coordinates I just clicked on. So that's what those 2 numbers are. But whenever I click on it, it's printing out hi, which is pretty cool. All right, so let's go ahead and say, so let's go ahead and figure out how we can do that. So let's go ahead and create this stuff, and then we can maybe say, hey, instead of saying hi, bob dot forward 100. Okay. Oh, there we go. We're in business now. There we go. So Bob's a bit shy. We click him, he moves a bit, right? World's like stupidest game now, but hey, at least it's some interaction, right? So what's going on here? So this program continuously runs, right, when we have the turtle program going, and it just waits for user, input. And most of the time, in most programs we write with turtles, it doesn't do anything, right? Here, though, we've said, if we click on Bob, I'd like it to run say hi. And apparently, if we do an on click, it needs 2 things, which is where you clicked on him. So I said, here's the X and Y coordinate. We don't use it. It's just required by the functionality of this, apparently. And so I say, on click, move forward like this. Move forward 100 things. Right? So right? Let's see. If I were to just put forward 100, let's see if that would do anything. No. Let's see. Would it say self.forward? Here I'm just being very hackerish. I don't know if it would work. Nope. Name self is not defined. Of course it's not. Okay. Bob.forward. Okay. Cool. Well, we have Bob. He exists outside of that function. Therefore, he can be called inside that function. Bad programming practice normally, but I can't see of any other way to currently get around it right now. So let's go ahead and, but if he moves forward all the time, he's just going to move off the screen, right? Let's go ahead and have him move in a random, turn in a random direction and move then. So how do we do random numbers in Python? Import, I'm going to guess random. And random dot next rand int. So let's go ahead and play around with this before we look too much. So I'm going to boot up idle for a second just so that we can see how this works. Okay. So here's idle, right? Always great to play around in idle. So we're importing another library here called random. Random.nextInt. Let's see what that does. It has no attribute nextInt. Random.nextInt. Random has no attribute nextInt. Random dot. Oh, was random. Sorry. Again, two programming languages. In Python, sorry, in Java, it's nextInt. Rand int. Is it this? Yeah. It needs two positional arguments, it says. Random dot rand int returns a range, an integer in range a through b. So if I put in 0 through 1, I'm going to copy this and paste it, by the way, a bunch of times. Random.randant 0 1 0 0 1 1 0 1 1 0 1. Everybody see what it's doing? This random.randint command. It's randomly choosing a number between 0 and 1 inclusive, right? So not inclusive exclusive, but like between both these numbers, right? It's and it's what we call uniform randomness, right? Which is that it is generating a random number between 0 and 1, and both have a 50% chance of going. So now if I try 1 and 3, it will generate a number between 1 and 3, 1, 3, and each number has a 33% chance of being, you know, of going, right? And we can kind of test that out here, right? We can kind of prove to ourselves that the things are, that this is like randomly distributed, okay? So I'm gonna write I'm just gonna write this. You don't need to necessarily follow. I'm just trying to show to you that this is random, okay? Or close to random, and randomly uniform. Import random, okay? num1, num2, num3 equals 0, 0, 0. And what we're going to do is that we're going to generate like 1,000 random numbers and see how many we get. Okay? For x in range 5,000. So we're going to generate 5,000 random numbers. We're not going to use x, so I'm just going to replace it with an underscore. We can use an underscore for the variable when we don't care about the variable, right? We just want to repeat something 5,000 times, right? And actually, it's best practice to like do something like this. Trials is equal to 5,000, right? Because I might be using that multiple times. All right? So here, what we'll do is we'll say random dot next, sorry, random dot randint will take in two integers, right? So 1 through 3. We'll say num is equal to some number between 1 and 3 inclusive, right? If num is equal to 1, num1 plus equals 1, else if, and I just simply do that out of habit, num equals 2, num2 plus equals 1, elif num equals 3, num3 plus equals 1. So if I see a 1, I increase the number of 1s I've seen. If I see a 2, I increase the number of 2s I've seen. And if I see a 3, I increase the number of 3s I've seen. And I don't know why I had a random colon there. And then when we're done, we will print out num1, num2, num3. Print out all three of those, and we run it. And if you look, they're roughly the same. They're not exactly the same. For one reason, for one thing, you can't divide 5,000 by 3, right? Let's go ahead and then change that to a multiple of 3, right? For instance, this 3, 6, let's see, 3, 6, 12, that's a multiple of 3. How do I know that's a multiple of 3, by the way? This is a trick that I don't know why they don't teach it in school. So if I add up all the digits and they're divisible by 3, then the whole number is divisible by 3. So 3, 6, and 1, 2 add up to what? 12. 12 adds up to 1, adds up 12, the digits add up to 3, which is divisible by 3. Therefore, it's divisible by 3. Don't know why they don't teach that. I don't even know where I learned that. Some random math trick, something. Anyway, that's divisible by 3. So, like, they should both all equal 1,000, right? If there's a 3,000 and it's evenly distributed, but they don't equal 1,000. Now, why is that? Because it's random, right? If you take out a coin, flip it 100 times, you're not going to get 50 heads and 50 tails. That's simply the most likely result. But it's only a bit more likely than 51 heads and 49 tails. You'll learn more about this if you take a statistics class or a probabilities class. But the point being is that it's just, uniformly random distribution means that basically this is close. And of course, the more trials that I do, well, the longer it's going to take. So maybe that was a bit of a mistake. Did I just hit? 300 million trials. Okay, that will take a while. Okay, that will take a while. Right, the more of these that I add, let's go ahead and do 3 million. You should be able to crunch through that, right? 3 million trials, that's going to take a while apparently too. But the point being is that the more trials you have, then the closer we'll be able to get to that actual answer. Oh, there we go. Right? And now they're within less than 1,000 of each other. So they're very close to randomly distributed. Anyway, so how can we use this? Well, what we'll do is that we've got random over here. We'll say direction is equal to random.rand int, and then we will have Bob turn anywhere between 0 to 360 degrees. Actually, it should be 1 to 360, because 360 would be basically going the same direction. So this is, and if I did 0 to 360, then it would be twice as likely that he doesn't go anywhere. And then he goes forward 1. All right, so now if we run this, oh wait, it's going to do the same thing because I haven't used the random direction. And now, yeah, let's turn this degrees. Degrees is equal to random.randint, bob.left degrees. Okay. And now if I click him, he just randomly turns, right? Look at that. He just scurries around. Right? That's pretty cool. Right? So you can actually, so this turtle thing is actually pretty complex with what you can do with it. It's pretty nice. All right. So there's an on-click command. That's not needed in any of the homework. I just thought it was cool to show you guys. In fact, I'm going to go ahead and like pretend that it doesn't even exist anymore because we don't really need it. I'm going to keep it over here on the top. Right? All right. So let's go back into the idea of more of that theoretical computer science that we do need. All right. So we've got Bob. He's a turtle, and we want him to. There's another thing he can do, which is actually pretty interesting, and that is Bob can actually say stuff to us, which is that he can, I believe it is, what? Is it right? Yeah. Bob.write. No, that's not it. Bob. What was it? Bob. Oh, come on. Did I really overwrite it? Interesting. Don't save. Save. That's okay. Let's see. Well, let's go ahead and see how to do it. Right. Yeah. Bob.write. Okay, I was right. All right, Bob.write. Bob.write. Hello. They're just pulling the wrong information, I think. Oh, Bob is not defined. Why are you saying Bob is not defined? He's a turtle. Oh, on click. Oh, I see. Yeah, I'm going to comment this out by putting it, just going to comment that all out. Okay, there we go. So now if we run this, Bob, oh, that's a bit hard to see. Hello. Yeah. Hello, how are you? My writing is super tiny. Right? Area can kind of see that something just appeared there. Okay, let's go ahead and make that a bit more legible, shall we? So there's a couple of things that we can do with Bob with text. So write takes it into between 1 and 3 parameters, right? So that's a common theme in Python, that things can take in multiple parameters. Here, with the write command, we can also put in true or false. By default, it's false. Right? By default, it's false. But if we put in true, something interesting happens. Bob travels to the end of what we just typed, or what just got typed there, okay? All right? And then the final thing over here is a bit different. We need what's called a tuple, which we'll learn more about later. But it's a tuple to define what the font is, right? So by default, it uses Arial of size 8, which is super tiny. Okay? So we'll just simply say Arial, and I'm going to bump this up to 20. 20 is going to look pretty good for a pretty big. Arial, 20, and normal. So within your parentheses, you want another set of parentheses, which define the font. So now if we run that, attribute has no, tuple has no, do I need font equals? Come on. Okay, yeah, I needed the font equals there. There we go. Not so tiny anymore. All right. So you can if you can take a guess over here, this kind of controls the type of font you want. This gives you the actual font family that you want, and this is the font size. So if I bumped it up to like 72, which is about as high as fonts go, it's going to be ginormous. Ridiculously ginormous, in fact. And also the font, just whatever we tell it to write just comes up all at once, even if we tell him to travel underneath it. I'm just going to make it, I'm going to turn it into Mono. I have that installed on my system. You can use any font that's installed on your system. You probably don't have Mono installed, but that's the one I'm using to type in, right? So I'm just making it look consistent with everything else I'm doing. See, and that changed the font. Hello, how are you? My writing is. Right, okay. So now, mind you, the message comes up all at once. I really would find it cool if I could get like a typewriter effect going here. I don't know, how'd you guys feel about that? So what I'll do is that I'll say message is equal to, he's going to write me a message, and I'm just going to cut this out. And right, no change. The first change I'm going to make over here is that I'm just replacing that, so no change actually. Right, it's the same thing that happens, right? I'm just using a variable there instead. And now, instead of actually like writing the message all at once, what I'm going to do is use a for loop. For letter in message. This iterates over the message, right? Every letter in, right? We remember that from our previous homework, right? Going over a string like that, that goes over every character in the string. So for letter in message, I'm going to tell Bob to write the letter. Right? Oh, that was cool. Let's tell Bob to slow down a little. Let's see if that helps. Bob.speed is equal to 1. Just put that somewhere. Hello, how are you? And now we've got kind of a typewriter effect going on over there. Oh, I wonder what happens if we break it up. Hello, how are you? Doesn't really do anything with the new line over there. Interesting, right? If we're doing it letter by letter. Interesting. So we can kind of typewrite it like that. Now that's pretty cool. All right. So strings come in many formats. So again, all this is going. I'm teaching you various things today. Random, you're never really going to see on a test too much, really. And if it is on a test, I'll have it like I'll give it to you. It's not going to be on this exam though, right? We'll revisit random more later. Okay. So we're going to go into the next topic here, and we'll reintroduce it with turtles. So let's go ahead. File reading .py. I have a plan for today, don't worry, it's actually pretty cool. So we're going to learn how to read files today. Okay? So let's talk about files on your computer. Okay? In general, there are two types of files. Okay? So the first type of file is the ones you've been working with so far, which are called text files. Called so because they're made up of guess what? Yeah, I know, right? It is. It's a surprise. It's not a trick question. They're called text files because they're made up of text. They can be anything that looks like a this. For instance, this Python file over here. This over here, which is Project Gutenberg's e-text of Shakespeare's first folio. Right, this is actually like 5 megabytes of text right over here. And you can read it. And that's kind of the defining feature of text. You can read it. Right? You can read this too, even though it's code that is in Java. You can like read it. You can know that it's not gibberish. You might not be able to comprehend it. Right? Similarly, this is a subtitle. This is a caption file for subtitling, and you can't read all of it, but it's telling you we're going to display these things. We're going to display this text between these times, right? Can't really understand it necessarily, but you can read it, right? And that's the defining feature of a text file. On the other hand, if I go over to here, right, right, if I go over here into videos and into lectures, right, where we have all these, where I'm currently recording our lectures. Right, here's the previous lecture. If I were to say, let's see, open in terminal over here, Vim, yeah, 2018 dash and Vim is just a text editor. 2018-11-04. I'm just going to choose one at random. 04/151 15-37. Yeah. There we go. 37. Oh, that wasn't specific enough. 37-21. Okay. So I'm going to open that up in Vim. This is not text. This is a binary file. This is the other type of file. It's a movie. And it's trying to read, and because I opened it in a text editor, it's doing its darn best to try to read it like it was human readable text. But it just can't. It's gibberish. Right? Is the point. Right? So broadly there's the two types of files. You have your text files, which can be read by humans and by computers, and you have binary files, which can only be read by computers or very psychotic humans. Right? So examples of binary files are Word documents, for example, and Excel sheets, right? You cannot open those up in text editors. You have to use specialized programs to read and write into those files. Same with movies, right? Those are binary files. You can watch a movie, but you need a specialized program to do it. You can't just like look through it, right? So when we read files, we'll be specifically reading from binary files, okay? Now, to read a file that's on your computer, if you want to make it easy for yourself, the file has to be in the location that your Python script is, okay? So in other words, let's see. So in other words, if we look over here in my file reading, so I created file reading.py, and it's in the, and I'm going to be reading this test file over here, okay? They're both going to be in the same folder. They're both going to be in the same directory. So that's kind of essential for getting file reading to work. So if you're not able to read the file, it's because they're not in the same directory. Okay? Everybody get that? So if you've got a text file and this file, you want them to be in the same directory. On an exam, you get to assume that if you're reading a file, and again, this is not going to be on the current exam. The current exam is going to be only up to the stuff you've learned so far. This stuff will help with the stuff because guess what? For loops are kind of useful everywhere. So now, in other programming languages, like if you've worked in C or in Java, reading a file is kind of a pain. Like, it is seriously a pain. All right? Python's there to take the pain away. Okay? So here's how we read a file. I'm going to go ahead and say data is equal to open, and open is the command to open up a stream to the file to speed so we can start reading it. And we're going to store that stream in data. So open, we give it the file name. My file is called testfile.txt. Right? You can name your you can create a text file somewhere else. You can download the one that I showed you earlier, or you can just read another Python file, which is actually pretty funny. So just give it a name as something else in the directory. Okay? So open takes two parameters. The first one is the file, and the second is the mode. Since we're reading a file, we put in R. There's three modes. There's read, and if there's read, can you guess one of the other ones? Right. Yep, there's write, which writes or overwrites a file, and then there's A for append, which is like writing, but instead of overwriting, you're adding to the end of a file. Right? You can imagine a use case for both. Sometimes you want to overwrite a file, and sometimes you'd like to add on to an end because you got more results. That's all you need to read the file. So if you can run it and you don't get an error, congratulations, you're reading the file. Or you've got access to the file. If you got an error, don't worry too much about it. You're just in the wrong directory or something, or you're not targeting. Again, try targeting a Python file in the same directory. if you're having issues. So I'll give everybody like a couple seconds to work on that. All right. So we've got this data here. So how can we use this? So we can read a file in a number of ways. The most, right, data is our file over here. I just don't call it file because because Python uses that word. So how do I use that? Well, text is equal to data.read. Okay? And then we'll go ahead. Right, we can't print the data, right? If we try printing the data, this is what's going to happen. Whoops. Well, first off, tell me invalid syntax because I accidentally hit 4 while I was hitting F5. It'll tell me it's an IO wrapper, right? It says that I'm going to use text_file.text read mode, and I'm going to read it in UTF-8, right? That's the default way. UTF-8 is the encoding that's used for most text these days. So the data itself, this is actually just kind of a socket that plugs in to read the stuff. So data.read over here, now if we print text, you get a 5, and it prints the contents of the file. Boom, just like that. This is because what it did is that it took the entire file and pumped it into and just stored it in string, which is called with the read command. That's pretty cool. It says ring ring, this is a string, there's another string, how many things can you put in this string thing? Is 3ads cat MPS slack gave the row, which is very impressive gibberish that I came up with. There's a method to my madness, I swear. Okay. Anyway, let's go ahead and see how we can. So there's another way. I think it's what? Read lines? Yeah, read lines. And then if we do that, it will break it up into individual lines. It creates a list of lines. Now, we haven't learned about lists yet, and we're not going to learn about them today. But once we learn about lists, this is another useful way to do it. But it's fully capable of breaking it up into lines for you. Notice all the /n's, right? Those were included when I just read it normally, right? When we did a /n, it would just print it out, right? And now there's one more way I like to read my file, which actually is which is my favorite way. And this is let me tell you, actually, this is the moment I fell in love with Python, when I did it this way. Because Python, again, you want it to be the least surprising. Now, again, I mentioned that opening files in other programming languages is a bit of a pain, right? To do it in Java, I have to do it like this. I have to say scanner is equal to new scanner, and then new file, and then test file.txt. Okay, and then semicolon there, and then to also do it in Java, so if I want to read it, I have to basically go while scanner dot has next line. This is in Java, so you can kind of ignore this. I'm just kind of showing you in comparison how easy Python is and how wonderful Python is. While scanner dot has next line, string line is equal to scanner dot next line, right? System dot out dot print line. So that's how you read a file. That's how you print out all the lines of a file in Java. Except wait, no, this won't compile because if I'm opening a file, that could fail, so it needs to be in a try catch block. Try. Okay. And you indent those, unindent this, and then catch exception E dot print stack trace. There we go. Okay, so that's how you read it in Java. Okay. So I was working on a project where I was reading some astronomical data and pumping it into a database, and I had to read the file. And I was wondering, okay, I've never actually had to read this in Python, and I was learning Python at the same time I was doing this, teaching myself. I'm like, I wonder though, would it work like this? Because it has the in keyword. For line in data. Print data. And much to my surprise, right? Oh, not print data, print line. For line in data, print the line. It worked. Now, why am I getting a line in between every line? That's because every line has a new line on the end of it, right? So it's printing out, so I'm printing out everything twice. But that works. If I wanted to remove I can, do this. There's two ways to handle that. End is equal to, that, right? And why does it still have spaces? Because there's a new line over here, there's a new line over here, there's a new line over here, a new line over here, and a new line over here, right? So that's why that was doing that. Or I can say print line dot, I think strip, which strips all the spaces above and below it, which is fantastic. So that's fantastic. We've got this here, which does it for us. All right. That's how you read a file in Python. That's pretty easy, right? All right. When we start using that in an assignment, obviously it will be stuff like analyzing that or splitting it up a bit more. But for right now, it's fairly easy. So now let's go ahead and integrate this into our turtle program. I was about to say Pertle program, which makes no sense. All right. So let's go ahead and just show that it works over here, right? The turtle program's in the same directory. So what I'm going to do is I'm going to delete this whole message thing that we have here. And instead what we're going to do with our turtle is that we are going to we're going to open the file, just like we did earlier. So data is equal to open, and you can open whatever you want, text, open test file.txt, then we say we want it to be read, right? So R. Okay, and let's go ahead and say data.read. So read all the data. Bob.write. Text is equal to data.read. So bob.write text. So if we run that now, right, it's going to be in that small Arial text. But he prints out the entire contents of the file, which is pretty cool. Okay, so let's go ahead and make that a bit bigger. Okay, Bob write. We'll keep it false for right now, and then I'll just simply steal this over here. Let's go ahead and bump this down to like 28. Okay, ring ring, this is a string, right? It's doing the whole thing there. And now, watch what happens if I do true. Right, it prints it, and then we have Bob, and then Bob travels to the end of it. It's obviously still too big for us, so let's go ahead and move Bob back a bit. Bob dot go to 0, -500. Right, go to just tells him to go to a direction. It's actually kind of a really nice command. Actually, that we need him to travel backwards on the x-axis, not on the y-axis. So -500, right? Oh, that was a bit too far back. And the text is just a bit too big. So we're going to go ahead and lower it to 20 and move him back 200 spaces. Ah! Nope. Accidentally closed it. Note to self, don't hit Control D. All right. All right. Here we go, 200. Boom. Here we go. Okay, and then he moves forward and completes it, right? And he's still drawing he draws the line because his pen is still down. All right. So let's go ahead and see if we can't get a typewriter thing going for him. right? So instead of doing the data.read here, let's go ahead and do for line in data. And then what we'll do is that we will print out we'll print out, instead of printing out text, right, because text doesn't exist anymore, we're going to switch this to line, right? Moving back, ring ring, this is a string, this is another string. Wait, that's not what I wanted, but it's what I told him to do, right? What I told him to do was for every line, write, and then move forward, and then write some more, and then move forward, and then write some more, and then move forward, right? Where's he moving forward? Where did I tell him to move forward? That's what the true does, right? If I put down false, watch what happens instead. It just comes up over each other because I tell him to write each line on top of each other. If I tell him to move forward, it actually moves forward. Oh, that's a bit of an obnoxious thing. So, okay. Bob, I want you to move up a bit. Oh, sorry. I want you to move up a bit because 200 over here. Okay, there we go. So we're going to tell Bob to move up there a little bit so that he can work a bit. Okay. So obviously what I want him to do is kind of actually move down as he's going, right? Right, I want to print out a line, then have him move down, and have print out a line. So true. Let's see. Can we move him back to index 0? Oh, it doesn't matter, actually. Right. Boom, boom, boom. All right, so you know what? I'll have you move back to 0 because that's, negative 200. We'll stay there for right now. All right, so we need to move him back to, so whenever he starts, we need to move him backwards a bit. Okay, so let's go ahead and we can actually get his position. We can say x comma y is equal to Bob dot position. This is actually another cool feature of the Python programming language, where we do Bob dot position, and it returns two variables, an x and a y variable, right? It returns Bob's x and y coordinates, so it can return two things, and so we store it in two variables, x and y, right? That's his x coordinate and that's his y coordinate, right? So now watch what happens if I tell him Bob dot go to x, y. Still going to look terrible, but writes it, and right, he's still overwriting everything, right, because he's just moving back to the beginning each time, right? So we need him to move down a bit. All right. So any ideas of how we can do that? Through the power of subtraction, right? It's like the world's stupidest power, right? 40 x. Let's try x, y minus 40. Right? So he moves here. Then if we tell him x, now if we do y minus 40, what's going on there? Well, what we do is that we get his position before he starts. Okay? Oh, and that's because there's just an empty line. That's what that is. Okay? So we get his position. What we do with our code is that we get our position before he starts. We say, what is your starting position? Your starting position is xy. Go ahead and write your line. You're going to get to the end of that line, right? Then I want you to go to where you started for your x position, right? So the x position isn't going to change, but I want you to go 40 down from where you currently are. So I want you to go back to where you started, but I want you to go 40 down from where you started. And by the way, your y hasn't changed at all. So, all right, let's go ahead and tell Bob when he's moving to put his pen up, bob.pen up. All right, and then when he gets back, we'll do bob.pen down. Right, so that when he's moving, we aren't going to get those diagonal lines. Okay. Ring, ring. This is a string. right? We still have this diagonal line because that's not part of our loop. How many things can you put into string? Right, and the lines don't really line up. That just has to do with it, right? This line goes to this line goes to this line goes to this, right? But that's okay. All right. So we're getting one line at a time. So let's see if we can't go deeper. So this is actually where you kind of see nested for loops in Python. You don't really see them too often, but you see them in situations like this where it kind of makes sense. So every line of this file, right, has a string in it, and every string is made up of characters or letters. So what we'll do is let me just close some of these. All right, we just do some of these, and so now let's go ahead and see 4 letter in line. This will make a bit more sense than the for loops you've been dealing with so far, even though it's a nested for loop. So 4 letter in line, bob.write letter. Okay? So now, oh, that's pretty cool. Right? I mean, relatively speaking. All right. So what's going on here with this for loop, right? So notice that this is a nested for loop, but it's going to be way easier to understand than those other nested for loops because it's a lot less abstract. For each line in the data, what are we going to do? We're going to store Bob's X and Y position. And then for every letter in that line that we are currently on, I want to write that letter and have the turtle move along with that letter. And I'd please like it to be in big, easy to read font, please. Once we have written all the letters, right, for every letter in the line, this is going to continue until we finish the line. Once we're done reading, we are going to tell the turtle, Bob, put your pen up. Go to X, which was where you started, and then I want you to go 40 down from where you started. Once you do that, put your pen down. Right? 4 letter in the line. 4 letter in the line. 4 letter in the line. Move to where you started. Move 40 down, 4 letter in line, print it out, then go to 40 below where you started, and then write that. Make sense to everybody? This is not too, right? This is a lot easier to deal with than the nested for loops we've been dealing with so far. Okay, and this is where we typically see nested for loops, right? And if we didn't do this in a for loop, we wouldn't kind of get the typewriter action of this going 1 letter at a time, right? When we do it like this, it kind of looks like Bob's typing it out for us, which is pretty cute. All right, so let's go ahead and see what else we can do here, right? I believe you all remember that we have slice notation, right? Line is equal to line, right? And then we have the slice notation. So if I wanted to go from the first character up to, but not including the 5th character, right, this is what it would do. Ing, his, snow, right? Everybody remember that? The slice notation? So let's go ahead and just double check that, right? Character 1 over through 1, 2, 3, characters 1, 2, 3, and then there was a space in each of these. 1, 2, 3 space, those are characters 1, 2, 3, 4, up to but not including 5. Right, everybody remember that? So, ing, his, blank, and then STH. All right? Oh, gotta reopen it. All right. So, and of course I can just put that over here, right? So there are 3 portions to this, right? There's the beginning, So you have basically your beginning, your stopping point, and your step, just like you do for range. It's exactly the same as range. Although there's a couple of interesting things you do that are consequences. For instance, if I just leave these all blank, it will just assume you want it from, if you leave these all blank, it will just simply assume you want to go all the way through the line, right? If you leave the beginning blank, it says you want to start at the beginning. If you leave the stopping point blank, it assumes you want to go to the end. And if you leave the third one blank, it assumes you want to go through every single one. Okay? So if we go through, say, if we do -1 over here, this means I want to go from the beginning to the end, but I want to do it backwards. It's pretty cool. String slice notation is actually very powerful. All right? And so what would I want to do over here if I wanted to do every other character? Okay, I wanted to do the whole line, but every other character of it. If I leave it blank, I have every character. Put in 2. Put way too much effort into that. So there is, so again, that read every other character, and it's a bit hard to tell with the other lines, but with this line, I blank hid a message in here, right, that, you know, makes it easy to check. So every other character, there. So once we are done with our exam, we're going to be learning a lot about string slice notation. And one of the wonderful, wonderful things about string slice notation is that lists use the exact same notation in Python. Strings and lists work exactly the same. Right? Strings and arrays in Java and strings and arrays in other programming languages don't. So that's what I've got for you today. Study up for the exam. Your exam is in your lab period, right? If you cannot make your exam for some reason, please let me know before your exam period, right?